Hello friends, welcome to G-Centric. So we will see in this lecture about some of the special cases related to the transient problems. Okay, so now if you see this circuit, before two problems we have solved where we had resistor, but here we have got two capacitors without the resistor connected in between. So that's why it makes the special case 1. Okay, so the question is, the switch is at position 1 for a long time and it is moved to position 2 at t equal to 0. So at t is equal to 0, it is moved at position 2. So we have to find all this parameter, that is voltage across C1 and voltage across C2 at 0 plus and 0 minus. So now we will move to the step 1. Okay, so our step 1 is nothing but at t equal to 0 minus. So at 0 minus it says that it is at position 1. So when it is at position 1, so capacitor C1 is with source and capacitor C2 will be without source. So C1 is with source and C2 is without source. Okay, so our circuit diagram will look like this is plus minus 100 volts. Okay, so this is 5 kilo ohms. This is closed and this will be open circuit. If it is with source, it is open circuit and this voltage will be Vc1 of 0 minus. Since C2 is without source, it will be initially relaxed. So when it is initially relaxed, Vc2 of 0 minus will be equal to 0. So now this is an open circuit. Since it is an open circuit, here the voltage drop is 0 volt. So this voltage source will only appear at the Vc1. So Vc1 of 0 minus will be equal to 100 volt. Okay. So now this will only be equal to Vc2 0 plus and Vc1 0 minus. So if you do this, then it will be wrong. Okay. It is wrong. That is because now at t equal to 0 plus, we will verify that step. Okay. At t is equal to 0 plus, the switch moves to 2. So here it is replaced with 100 volts. Okay. So capacitor is short circuit and this capacitor will be short circuited. Okay, so this is Vc2 of 0 plus. So now if you see that KVL will be violated. Okay, it should be equal to 0, which is not equal to 0, but here it is equal to 100 volts. Okay, so this is the violation of the KVL. So this value will not be true for the step 2 will not be true for this circuit diagram. Okay, so now to find out that why is it happening, it is the main thing. Okay, so we will redraw the circuit with switch at position 2. So this is C1 and this is C2. Okay, C1, C2 and the voltages across them will be Vc1 of 0 plus and Vc2 of 0 plus. If they have to be, in the previous case we have seen there was a resistor here, but in this case the resistor is absent. So immediately instantaneously this C1 will charge the capacitor C2 because C1 is charged capacitor and C2 is uncharged capacitor. Within no time this C1 will charge the C2. That is why time constant over here will be 0 because R is not present. If it's RC circuit, it will be time constant is R into C. So R is 0. So 0 into anything will be 0. Hence the time constant is 0. Ideally there will be no time delay to charge this C2 capacitor. Okay, but there will be some amount of fraction of microseconds which will take delay to charge this C2. Okay, so ideally if we assume that it is with no time it is getting charged, then we can use constant charge theorem. So we have seen in that previous lecture what is the constant charge theorem. So Q of 0 minus will be equal to Q of 0 plus. So which means that Vc1 of 0 minus will be equal to Vc2 of 0 minus. Sorry, this is plus. Okay, so our formula says that this will be equal to Vc1 of 0 minus. Okay, Vc1 of 0 minus. So Vc1 of 0 minus into C1 plus Vc2 of 0 minus into C2 divided by C1 plus C2. Okay, so this is nothing but the impulse. Why it is happening? It is because of the impulse current flowing in this circuit. Okay, so we have seen the formula also, which says 1 by C 0 minus to 0 plus I of t dt. Okay, so this is nothing but equal to Vc of t. So this will be equal to 0 only when it will not be valid, only when impulse function is present. Okay, so now here, since the impulse function is present, we will not equate this to 0. Okay, it will not be equal to 0. So now, before that, till now we had seen that t is equal to 0 minus at t is equal to 0 plus, it was like we were having invalid or we did not use impulse. Okay, impulse was not present in these cases. That's why we used to say directly that Vc of 0 minus will be equal to 0 plus. Since now this impulse is present, this formula we have to use. Okay, this will be a valid formula, and since it is instantaneously charging C1 and C2, there will be impulse current flowing in this circuit. Okay, and also it will allow sudden change of voltage. Okay, so this is the sudden change of voltage. So Vc2 of 0 minus will not be equal to Vc1 of 0 plus. So now coming to this one, coming to this formula, Vc1 of 0 minus is 100 and C1 value is 20. Initially Vc2 is relaxed, so 0 into C2 divided by 20 plus 525. So this will be 480 volts. Okay, so this is nothing but our Vc1 of 0 plus, which is also equal to Vc2 of 0 plus. So this is the special case 1, and we will see even the special case 2 where there is an ideal capacitor with ideal voltage source. So to conclude this statement for this question, we have got two capacitors of different charges. One is 20 microfarad and 5 microfarad, and there is no resistor present in between them. Okay, so the circuit looks like this at t is equal to 0 plus, okay, which indicates the impulse current flowing in the circuit. Because of that, it will allow sudden change of voltage. So the meaning of impulse is only it will be immediately charge this one C2 capacitor. So what we have to use to find the values at 0 plus, we will use the constant charge theorem, and it will be equal to Q of 0 minus will be equal to Q of 0 plus, and we will solve and we will get the answer as 80 volts. Okay, we will see some more cases based on this impulse thing. Okay, so coming to this question number 190, which is special case 2. So here there is an ideal voltage source connected to the capacitor 2 farad. Okay, so we have to find Vc of 0 minus and Vc of 0 plus. So initially t is equal to 0, it will be closed, the switch is closed. Before that it is open, so it is like without source. Okay, so if it is without source, this is step 1, we will write without source. So when it is without source, initially relaxed. So if it is initially relaxed, then Vc of 0 minus will be 0 volts. So now this is not equal to Vc of 0 plus. Okay, so this is not equal to Vc of 0 plus, because if you verify step 2 at t equal to 0 plus, so this is at t is equal to 0 minus. Okay, so the switch is closed, so it will feel like with source. Okay, so when it is with source, it will be short circuited, and here it is 100 volts. Okay, so when it is of 100 volts, then the again KVL is violated. So we cannot use this method to follow or to find the Vc of 0 plus. Okay, so we will have to redraw the circuit. Okay, we will redraw the step 2. At t equal to 0 plus, the switch is closed. We will write as it is the circuit. This is 100 volts and the switch is closed here. This is 2 farad. Okay, so this is 2 farad. Now we have to find the voltage at Vc 0 plus. Okay, so to find that, there is nothing, we have reached the dead end. So whenever we see that we have reached the dead end, we will use the Laplace method. Okay, so this will convert it to 100 by S. So this is 4 volts. Okay, we will take it as 4 volts. Okay, so this is 4 volts. So now this is, when you convert this, it will be 4 by S. So in the next lecture we will see the Laplace transformation, how we will do. For now, this is, since it is a very simple circuit, we will apply basic formulas of the Laplace transform. So this is 2 farad, it will become nothing but 1 by Cs. Okay, so the value of C is 2, so it is 1 upon 2s. Okay, so now we can apply the, to find this Vc of 0 plus, we can apply the KVL. Okay, so how do you apply the KVL over here? First we have to find the current, then only we can see what is Vc of 0 plus. So in the circuit we have to find I of S. So to find I of S, it's nothing but 4 volts. Okay, 4 volts divided by 1 upon 2s. So it will be, when it goes to the numerator, it will be 2s. So 4 into 2 is 8 ampere. So this is the current flowing in it. Okay, so this is, if you take the ILT of this one, that is inverse Laplace transform, you will get I of t equal to, so this is when there is only a constant, then it will be a function of impulse. Okay, so now if you observe, there is an impulse current flowing in the circuit. Okay, so suddenly everything, without delay, there will be, the capacitor will be charged. Okay, so tau into R into C, here the time constant is 0. So now we have got I of t, so we will see Vc of 0 plus by this formula from 0 minus to 0 plus I of t dt. The value of capacitor is 2, 0 minus to 0 plus I of t value is 8 of del t into dt. So when 8 comes out, it's a constant, it will be 4, and 0 minus to 0 plus del of t dt. So this will be equal to 1. So our answer is 4 volt Vc of 0 plus. Okay, so whenever the impulse is given, which is the special case 2, okay, we will solve in this method. We will convert this into Laplace, then we will find the current if it is a capacitor, inductor if it is, we will see in the next special case for the inductor. Okay, so when there is inductor, we will use to calculate voltage, and then we will apply the formula. Okay, so we will see now for the inductor. Coming to this special case 3, where we have got inductor, okay, which is replaced by capacitor, and the switch is closed at t equal to 0. We have to find IL of 0 plus and IL of 0 minus. So coming to our step 1. So for step 1, we will analyze at t equal to 0 minus. So it is without source. If it is without source, that means the inductor is initially relaxed. Okay. So if it is initially relaxed, then the current through that will be IL of 0 minus will be equal to 0 ampere. Now again, this is an ideal current source which is connected to the inductor without any resistor in between. Okay, so it will be 0 minus but not equal to 0 plus. So again, because KCL violates, if you see step 2, when it is closed, then it will feel like, so this is current source. Okay, so it is current source, it is with source, it will be open circuit. So when it is open circuit, 4 ampere of current, it does not get a return path, open circuit, hence KCL fails. So we cannot use this step 2 for calculating IL of 0 plus. So now we will move on to taking the Laplace transform. So at t is equal to 0 plus, our circuit will, this is 4 amperes. Okay, so if it is 4 amperes and we have got inductor and voltage across this is VL of 0 plus with 2 Henry. Okay, so now we will find out the voltage in this one. So voltage is found out by voltage VL of 0 plus is nothing but current in the circuit and 2 Henry. Okay, that is 8 amperes. Okay, before that we have to convert this into Laplace domain. So it will be 4 by S, and this is nothing but 2 into S. Okay, so that is because Ls is the Laplace transform of the inductor. So when you do that, this is 4 by S 2 into S, this S and S gets cancelled. So our answer will be 8 amperes. So this is the voltage we got. Now to find the current from 0 minus to 0 plus V of t dt. Okay, so this V of t is nothing but this VL of 0 plus. Okay, so L is 1 by 2. This is 8 Henry, and now if you take the ILT of this one, so V of t will be 8 del of t. Okay, so this will be t. Okay, so now this is the inverse Laplace transform. So if it is a constant, we will get impulse. So 8 del of t dt. So 8 if you take out, it will be 4. This is 0 minus to 0 plus del of t dt, and this will be equal to 1. So our IL of 0 plus is nothing but equal to 8 amperes. Okay, so this is 8 amperes, which is not equal to 0 amperes at 0 minus. Okay, we will see now taking two inductors having different Henry values. Okay, so in the first case we have seen two capacitor values having different charged capacitors. Now we will see the constant flux theorem based on the two inductors of differently valued. Okay, we will see for the next case. So coming to question number 192, so we have got two inductors of different values. One is 2 Henry and the other one is 1 Henry. Okay, and this we have got resistor, and the question says that the switch is closed for a long time and open at t is equal to 0. So this switch was closed for a long time and it gets open at t equal to 0. Okay, so we have to find the values of I of 0 plus and I of 0 minus. So in this case it will be impulse voltage. So in the previous case we have seen, okay, which if it is in the case of inductor it will be impulse voltage. If it's case of capacitor, then impulse current will be flowing in the circuit. Okay, so now for this one it says it is closed. So when it is closed, it will become a short circuit path. So this is our step 1. Okay, so when it is short circuit, every current will flow through this branch. It goes in this way. So this circuit is not valid. Okay, and also this 2 Henry, if it is with source, what will happen for it? It will be short circuit. Okay, so this one, this is 12 volt and this is short circuit, this is 4 ohms, and this one does not have, this is a short circuit path. Okay, we can draw it like this so that we can understand that this branch has no value. So and the current flowing in this will be IL of 0 minus. So which current it will be? It will be of 2 Henry. So we can write it as 2 Henry. Okay, so if it is of 2 Henry, 0 minus, current is 12 over 4, 3 ampere, and this is not equal to I2 Henry at 0 minus. Okay, that is because the KCL will fail. Why? When the switch is open, okay, this will be like this, everything will be with source. Now this will be replaced with this open circuit inductor and with the current source of 3 ampere. Okay, and since initially it was not charged, it will also be open circuit. Okay, so when it is open circuit, the current that is 3 ampere which should flow will not get a return path to this source. That is why the KCL will fail. Okay, so if you just draw this for some time, this is like this. Okay, 3 ampere, and this is open. So this will be also open. This is resistor. Here is one more resistor. Okay, so this is nothing but this 3 ampere will not get the return path. So hence what will happen? KCL is fail. Okay, so when KCL fails, we cannot apply this thing, that is I2 Henry of 0 minus will not be equal to, this is 0 plus. Okay, that will not be equal to 0 minus. Okay, so now we will come to step 2. Step 2 at t equal to 0 plus. So now what happened till now? We have seen that at 0 minus, this we will take this as L1 and this will take as L2. So L1 is with source, L2 is without source. Okay, so when it is without source, I1 Henry at 0 minus equal to 0, again which is not equal to I1 Henry at 0 plus. So we will see how to find this using the constant flux theorem. So for the capacitor we had seen constant charge theorem, and here we will see constant flux theorem. Okay, so coming to step 2, we'll apply constant, okay, we'll apply constant flux theorem. Okay, so what does the flux constant theorem says that? So this inductor at 2 Henry will instantly give the voltage for this one, okay, at 1 Henry. This will be instantly stored. I mean energy will be supplied for this one. Okay, so because of that what will happen? Flux in both of them will be same. Okay, again here also tau is equal to L by R is not present, okay, we cannot use the R, so it will be 0. So again 5 at 0 minus flux, that is at 0 minus will be equal to 0 plus, okay, and the voltage that is here is nothing but impulse voltage. Impulse voltage. So when charges, the fluxes are equal, we can write this phi of 0 minus as L into, okay, we can write this as L into I of 0 minus. So this is nothing but, where did this come from? L is equal to n phi by I. So n is still, we do not have anything, it's 1. So L into I will be equal to phi, which is written over here. Okay, we know the value of L, that is nothing but, this is we are calculating for 2 Henry. Okay, we will write it as 2 Henry. So L is 2 and the value of I of 2H is 3 ampere. So which will come as 6 Webers. Okay, this unit will be in Weber. So once it is, we have got this one, this is also similar to phi of 0 plus. Okay, that is nothing but equal to L I to H at 0 plus. So we want this value. So to calculate that value, we know this is phi of 0 plus is 6 because both are equal. So this is nothing but L is 2 Henries. Okay, so because see now at t is equal to 0 plus we are calculating, it will be a series circuit. So this 2 Henry and this 1 Henry get added up. So it will be equal to 3 into I of 0 plus. If you call this 2 Henry as 1 Henry also, it will be correct because it's a series circuit. So I of 0 plus, we will get it as 2 amperes. Okay, so this is how you will calculate the theorem using this constant flux theorem. Okay, so we will now see where for the Laplace transform we can conclude 2 situations where and all we can apply. So one is, so first thing, when we have got multiple time constants, and second, whenever there is impulse response. Okay, it can be either voltage or current. Okay, so this Laplace transform, it gives us directly general equation. So in the next class we will see how it will give us the generalized equation. Okay, so whenever they ask for generalized equation like I of t or V of t, then we will use Laplace transform. If they ask for specific values like I of 0 plus, V of 0 minus, we will use time domain analysis. Okay, so in the next lecture we will see the Laplace transformation using the for the transient analysis. Thank you.